Hey everyone, and welcome back to CodeMechanic. Ever wonder what happens in that magical moment when you turn the key and your car roars to life? It's not magic, it's engineering. And today, we're re-diving deep into one of the most critical systems in your engine. The ignition system. This is the system that turns a simple spark into the raw power that moves your car down the road. So, buckle up, because we're about to demystify the spark and explore how your engine truly comes alive. Let's start with the basics. What is the goal of the ignition system? Simply put, its job is to create a very high voltage spark at the perfect time to ignite the air fuel mixture inside your engine's cylinders. This controlled explosion is what pushes the piston down, turns the crankshaft, and ultimately sends power to your wheels. Think of it as the starting pistol for the race that happens thousands of times every minute inside your engine. It all begins with your car's battery, which typically provides a low voltage, around 12 volts. But 12 volts is nowhere near enough to jump the gap on a spark plug and create a spark. We need tens of thousands of volts. So, how do we get there? This is where the star of the show comes in. The ignition coil. The ignition coil is essentially a step-up transformer. Inside, it has two sets of wire windings wrapped around an iron core. A primary winding and a secondary winding. The primary winding has a few hundred turns of thicker wire, while the secondary winding has tens of thousands of turns of very fine wire. When you turn the key, 12-volt power from the battery flows through the primary winding, creating a magnetic field around the coil. Now, here comes the crucial part. The engine control unit, or ECU, suddenly cuts the power to this primary winding. When the current stops flowing, that magnetic field collapses instantly and violently. This rapid collapse induces a massive voltage spike in the secondary winding. Thanks to the huge difference in the number of wire turns, that initial 12 volts gets multiplied into something like 20,000 to 50,000 volts. Or even more. It's an incredible display of electromagnetic induction. This ultra-high voltage now has a mission. It needs to get to the spark plug. It travels from the coil through a thick, heavily insulated spark plug wire to its final destination. Now we're at the business end of the system, the spark plug. The spark plug is a surprisingly simple but robust component that sits at the top of each cylinder. It has a central electrode and a ground electrode, with a precisely measured gap between them. When that voltage pulse arrives from the coil, it's desperately looking for a path to ground. The air and fuel mixture in the gap is normally an insulator, but with tens of thousands of volts pushing against it, the electrical pressure becomes too much. The voltage ionizes the gas in the gap, turning it into a conductor and allowing a powerful spark to arc across from the central electrode to the ground electrode. This spark is incredibly hot, and it instantly ignites the compressed air-fuel mixture in the cylinder. This creates a rapid expansion of gases on explosion that forces the piston down with tremendous force, and this is where the power comes from. But here's the most critical part of the entire process: timing. The ECU doesn't just send a spark whenever it feels like it. It calculates the exact moment to fire the spark plug based on engine speed, load, temperature, and many other factors. This is called ignition timing. If the spark happens too early or too late, the engine will lose power, run rough, or even suffer damage. Modern ignition systems are incredibly precise, ensuring maximum power and efficiency with every single combustion event. So, to recap, your battery provides low voltage power. The ignition coil transforms it into super high voltage. The ECU times the release of this energy perfectly, and the spark plug delivers the final lightning bolt that ignites the fuel and creates the power that you feel when you press the gas pedal. From a simply 12-volt battery to a 50,000-volt explosion, all happening in a fraction of a second. It's an amazing process that keeps your engine running smoothly. I hope this breakdown helps you appreciate the incredible engineering that is happening under your hood every time you drive. If you found this explanation helpful, give us a thumbs up and hit that subscribe button for more deep dives into how your car works. Thanks for watching CodeMechanic, and we'll see you in the next one.